All matter is made up of atoms. This is something we now take as a given, and one of the things you learn right back at the beginning of high school or secondary school chemistry classes. Despite this, our idea about what an atom is are surprisingly recent. As little as 100 years ago, scientists were still debating what exactly an atom looks like. This graphic takes a look at the key models proposed for the atom and how they changed over time. Though our graphic starts in the 1800s, the idea of atoms was around long before. In fact, we have to go all the way back to ancient Greece to find its genesis. The word atom actually comes from the ancient Greek and roughly translates as indivisible.
Democritus was an ancient Greek pre-Socratic philosopher born in 460 BC of Deira, Greece. Primarily remembered today for his formulation of an atomic theory of the universe. The theory of Democritus held that everything is composed of atoms, which are physically but not geometrically indivisible, that between atoms there lies empty space, that atoms are indestructible and have always been and always will be in motion. Democritus proposed the earliest views as the shapes and connectivity of atoms. They reasoned that the solidness of the material corresponded to the shape of the atoms involved. Thus, iron atoms are solid and strong enough with hooks that lock them in place. Water atoms are smooth and sliding. Salt atoms, because of their taste, are sharp and pointed. And air atoms are light and whirling, pervading all materials.
John Dalton was an English physicist and chemist born on the 6th of September 1766 in Cumberland, England. He is best known for introducing the atom theory into chemistry. John Dalton formulated the first modern description of it as the fundamental building block of chemical structures. The solid sphere model was the first atomic model and was developed by Dalton in the early 19th centuries. He hypothesized that an atom is a solid sphere that could not be divided into smaller particles. He came up with this theory as a result of his research into gases. He realized that certain gases can only combine in specific proportions. Dalton developed the law of multiple proportions, first presented in 1803, by studying and expanding upon the works of Antoine Lavoisier and Joseph Proust. Dalton believed that the atomic theory could explain why water absorbed different gases in different proportions. Dalton also proposed that each chemical element is composed of atoms of a single unique type, and though they cannot be altered or destroyed by any means, they can bind to other atoms to form complex structures or chemical compounds. Since Dalton achieves his conclusion by experiments and examination of the result of an empirical fashion, this is marked as first truly scientific theory of the atom.
Sir Joseph John Thomson was a British physicist, born on 18th of December 1856 in Cambridge, England. Thomson discovered that the atoms wasn't as indivisible as previously claimed. He carried out experiments using cathode rays produced in a discharge tube and found out that the rays were attracted by positively charged metal plates but repelled by negatively charged ones. From this, he deduced the rays must be negatively charged. By measuring the charge on the particles in the ray, he was able to deduce that they were 2,000 times lighter than hydrogen, and by changing the metal the cathode was made from, he could tell that these particles were present in many types of atom. He discovered that electron, thought he referred to it as a corpuscle, and shows that atoms were not indivisible but had smaller constituent parts. This discovery would win him a Nobel Prize in 1906.
Ernest Rutherford was a New Zealand-born British physicist
Born on 30th August 1871 in Brightwater, colony of New Zealand, his contribution on development of the atom was his experiment called Rutherford gold foil experiment. Rutherford fired positively charged alpha particles at thin sheet of gold foil. Most passed through with little deflection, but some deflected at large angles. This was only possible if the atom was mostly empty space, with a positive charge concentrated in the center, thus creating the nuclear model. In summary, Ernest Rutherford postulated the nuclear structure of the atom, discovered alpha and beta rays, and proposed the laws of radioactive decay. He received the Nobel Prize in Chemistry in 1908.
Niels Bohr was a Danish physicist born on October 7, 1885 in Copenhagen, Denmark. In 1913, he proposed a theory for hydrogen atom based on quantum theory that energy is transferred only in a certain well-defined quantities. Electrons should move around the nucleus but only in prescribed orbits. When jumping from one orbit to another with lower energy, a light quantum is emitted. Bohr modified Rutherford's model of the atom by stating that electrons move around nucleus in orbits of fixed size and energies. Electron energy in this model was quantized. Electrons could not occupy the values of energy between the fixed energy level. His model is called planetary model.
Erwin Rudolf Joseph Alexander Schrödinger was a Nobel Prize-winning Austrian-Irish physicist born on the 12th of August 1887 in Vienna, Austria-Hungary. He developed a number of fundamental results in quantum theory. The Schrödinger equation provides a way to calculate the waves function of a system and how it changes dynamically in time. He was the author of many works on various aspects of physics, statistical mechanics and thermodynamics, physics of dielectrics, color theory, electrodynamics, general relativity, and cosmology. And he made several attempts to construct a unified field theory. A powerful model of the atom was developed by Erwin Schrödinger in 1926. Schrödinger combined the equations of the behavior of waves in the de Broglie equation to generate a mathematical model for the distribution of electrons in an atom.
Atoms are very important in this world. It helps people understand how elements of this world do, and that's why we need to learn and discover more to help our society and also our planet.